So looking at the concepts of scalar and vectors now, again, pens down, we don't need to write anything, just need to listen. Looking at the concept of scalars and vectors, but rather than dropping terms like magnitude and directional component, I think it's easier to teach you a couple of examples of a scalar and a vector. So distance and displacement are talking about the same sort of thing. So they've got some similarities and some differences. The similarities between the two is that they're both measures of length. If you run in a straight line, will your distance and your displacement be the same?
Yes.
Okay, didn't even get to finish my question, but yes, they will be the same, not different. Okay, the moment you turn, that's when they change. Whether that's turning even a slight bit, 90 degrees or 180 degrees back to where you started, then they become different. When you return to your original location, what is your displacement? Zero. Very good. So, they are both similar in the fact that they are both measures of length. What's their unit therefore? Meters. Okay, so I'd put in brackets here meters. There's also, you could use other units of length like kilometres, centimetres, millimetres, whatever you like. So they're both measures of length. How are they different?
I said displacement is the distance from a point, and then when the direction is from that point to a straight line to the other. That makes sense.
So let's just clarify that.
Right.
So displacement is what?
So when you start at one point and you go straight and then you turn at whatever angle or whatever, and then you go to another point and stop there, it's the distance from the first point to the second point with straight lines.
Very good. So I'm going to use a term, as crow flies. Do you know what that means? As the crow flies? Straight line. As the crow flies. Straight line. I might give myself a bit more room here. Straight line to, or between, final and start point. I might do distance somewhere else. What does it need? What should a displacement have? Tom? An origin?
Direction.
A direction. What about distance? How is distance different? I'll do that in red over here.
It is just how far you traveled overall.
Yep, so distance in the red, total length travelled. And again, much like scalars and vectors, that doesn't make a lot of sense until you actually go through and solve some problems. So here I've got Bob runs 100 metres north, turns east and runs 50 metres. What is his distance? So alright, distance equals 150 metres. I'm not going to write 100 plus 50 metres, you know how I did it. Easy, right? Displacement's a little bit trickier. What do we have to do for displacement? Logan? Pythagoras. So that's implying you've got a right angle triangle. Wonder how we can set this up. Do we know anything about that triangle? Damon? Yep, so it's 100 metres. What else do we know? 50 metres across, and what do we want to know? Hypotenuse? We'll call it x. What's the equation for Pythagoras?
A squared plus b squared equals c squared.
Which is which? Yep.
A is 100 metres, a squared is 100 metres squared plus 50 metres squared is equal to x squared.
Okay, does it matter if A was 50?
No.
What's the only thing that matters when you're using Pythag? Well, C must be the hypotenuse, so in this situation x. So as long as your C is your longest side, you're in a good spot. Now, only can be used for right angle triangles. Some people will teach you, for example, b squared equals c squared minus a squared. Why won't I teach you that?
Because all we have to do is rearrange it.
Learn one equation, rearrange it. If I was asking you for that length, you would just rearrange, subtracting a squared from both sides, and you'd find b squared that way. Learn one thing, understand how to get the others. So a squared is 100 squared plus 50 squared equals c squared. That'd be 2,000. That'd be what? 1,0,0,0 plus 2,500 equals c squared. How do I do that? How do I rearrange to get c? Square root. I should make that x now. Sorry, x. Square root of 1,2,5,0,0 equals x. What does that equal? 111. Always ask ourselves, does that sound reasonable?
Yes.
Okay, if it was say 98, would that be reasonable? Why not? Shorter than the 100 metres. Okay, if it was 400 metres, would that make sense? Okay, so always keep a little check on, does that sound like a reasonable answer? Is my answer done? What do I need to include? Direction. Now there's two ways of doing this. A simple way and a more complicated way. What's the simple way? Harry?
Rereading the question and finding point A and point B.
Yep, so which direction is 111.8 metres?
Northeast.
Northeast, very good. And to be honest, that's probably all I'll ask of you in this course. If I wanted you to go a little bit further, how could you do it? Yeah, you could add a sentence. That'd be a good process, but it wouldn't be any more complicated. How could I make it show? How could you show a little bit more understanding? Remember?
Could you use an angle?
You could use an angle. How could I find an angle? What angle would I be looking for? Well, I know this one's 90. Was it 45 degrees or? Does that feel like it'll be 45 degrees?
Yeah.
I disagree. I don't think it'll be 45. If it was 100 metres, then it would be 45 degrees. 45 means it should go up as far as it goes across. What angle do I want? Do I want this angle here? Or do I want that angle there? The bottom or the top? I want the bottom.
That's the origin point.
That's exactly what I want to know, how far from his origin and in what direction from his origin. How would I find that angle? Tree. What sides do I know? Adjacent. Oh, do I know any other sides? And the hypotenuse. So I can use whichever trig identity I want to find that angle. You will be required to do that in senior. I probably won't ask you to do it in this exam.
Why do you want that one, sorry?
Why do I want this angle?
Yeah.
So let's just say it's a little bit I think it's a little bit less than 30 degrees. But let's just say it's 30 degrees for argument's sake. I don't want to do the trig. If that was 30 degrees, then I could say Bob has travelled 111.8 metres, 30 degrees north east, or north 30 degrees east. Does that make sense? And that's just so if someone wanted to recreate that scenario, could they do it?
Yes.
They got to Bob's origin, put the compass to 30 degrees and walk 111.8 metres, and guess where they are? Right where Bob was. Happy with that?
Yes.
Very good. Let's go to my next question. All right, it took Bob 30 seconds to complete this run. What is Bob's speed? The equation for speed is what? Thanks, Nick.
Speed equals distance over time.
Very good. Do I know my distance?
No.
I'm hoping I know my distance. Unless you did question 3 before you did question 2, you should know your distance. 150 metres. I need to put metres in why?
So you know the unit of measurement?
So I know the unit that I'm going to get at the end. Divided by
30 seconds.
30 seconds, and I get what? 5
Meters per second.
metres per second. Very good. If that was 150 kilometres in 30 hours, that would be 5 kilometres per hour. If I had kilometres and seconds, what would I have to do? I'd divide one of my units to get it to the right. amount. Happy with that? What's his average velocity? Now, I very briefly spoke about the velocity equation. What do we think it is, Nick? You can double up.
V equals displacement over time.
Displacement over time. Now, what's the difference between displacement and distance?
Displacement is how far away from the origin they are, and the distance is how far they've travelled.
Very good. So to signify that, Adam, we use a capital D instead of a little d. Now in senior, they might use S, okay, they might use X, they might use a whole range of different symbols to denote displacement and distance. In this semester, we will be using capital D because I'm going to try and simplify it as much as possible. But you need to be pretty flexible with which symbol you're using and what that means. So do I know my displacement?
Yes.
What's my displacement, Tom? 111.8 divided by my time. What have I forgotten? My measurement, very good, which is meters and seconds. What else have I forgotten? Yep, the angle or the direction. So what's my direction? I need to know the direction he's travelling. Otherwise I couldn't recreate that, could I? So what have I got?
3.7.
3.7 metres per second northeast. Should velocity ever be greater than displacement?
No.
Velocity ever be greater than speed, sorry?
No.
Should displacement ever be greater than distance?
No.
No. Seem reasonable?
Yes.
Very good. Okay. Keep going. Actually, I'm going to get you to go to the third page of your workbooks now. And can we go through that activity?